All right, Jamb 2026 candidates, I want us to quickly look at something before we start the lecture for today, okay? So in one of our previous lessons, we treated Snell's law, okay? And something was omitted here. So if you jotted down in your notes, please quickly go and make that correction. Something was omitted, okay, here. And because it's already a pre-produced lecture material, we can't make the correction. We later went to make the correction, and now I am making the correction here in the lesson. Snell's law is the law that describes how light ray bends or refracts when it changes medium, okay? Of course, we know that when light ray passes from one medium to another, the speed of light changes. If it passes from a less dense medium, such as air, into a denser medium, such as glass, the speed will change, okay? The denser the medium, the slower the speed of light in it. The denser the medium, the higher chances or the higher possibility of the light to refract or bend, all right? So the Snell's law for refractive index is given as N1, which is refractive index 1, sine I, which is angle, sine of the angle of I, which is angle of the incidented ray. That's the incidented ray of light, the ray of light from the source, okay? Is equal to, is equivalent to N2, which is refractive index 2, sine the angle of the what? The refracted ray, okay, which is the R, okay? So this is the what? This is the what? The formula of Snell's law, or this is the relationship of Snell's law. This shows Snell's law, and that's that for the correction. So get your pen and your notebook so that you jot down whatever you understand in this lecture. Be also aware that this short and concise material is for preparation of Jamb UTME, especially if you have no time left. It is very short, so you can quickly look at everything, okay? It covers the whole syllabus, so you can get this file for 1K. For now, it's still 1K. I don't know what will happen tomorrow, so send me a DM. Look at my profile. You are going to find my phone number there. Send me a DM and get this file. So get your pen and your paper to jot down whatever you understand in this lecture. Do not joke with that. So today we are looking for the conditions for total internal reflection, TIR. This is very important. Jamb loves repeating question here. Total internal reflection. Conditions for total internal reflection. First of all, we have to understand what total internal reflection means. Total internal reflection is the reflection of light ray from another medium, okay? This one, now when we are talking about refraction of light, okay? We are talking about when light ray falls on a medium and it enters inside the medium, it refracts, it bends, and it comes out, it reflects outside. Now we are talking about total internal reflection, okay? What happens when light ray enters a medium, goes in that medium, and comes out of the medium, okay? Remember, reflection is the bouncing off of light ray, okay? So that's total internal reflection. The cascade of what happened when light is incidented, okay, upon a medium, and the light enters the medium and it bounces off, okay? The light is bounced off as a reflection. That's total internal reflection, all right? So it's coming from within, within, all right? So light must travel from a denser medium to a less dense medium. These are the conditions for total internal reflection. Like I said before, I'm telling you that it is like the reverse. What happened inside that internal system when light enters? You know the normal law of refraction, okay? Light enters, okay, incidented light enters, it enters inside from the less dense medium to denser medium. But here, the light ray must travel through what? The denser medium to less dense medium. It's just like light ray will come pass inside water, enter inside the water, come out back, bounce off into the air, okay? The water is a denser medium. The air is what? Less dense medium, all right? So the second one is the angle of incidence must be greater than the critical angle. The angle of incidence, that's the angle at which the light ray was incidented into this medium, must be what? Greater than the critical angle. As simple as that. So know these two conditions for what? For total internal reflection. So what are the applications of total internal reflection? The first one is in optic fiber or fiber optic, okay? That thing you use to view inside closets is flexible with camera to view inside a closet, okay? It works with the principle of total internal reflection, true reflection. Most of the time, now mirror the day inside, okay? Mirror and light, all right? So it's also applied in prisms, okay? Prisms like those glass prisms, and so on and so forth, okay? Prism is just something that has dimension, okay? It has a dimension used in optics, okay? It also applies in mirages, okay? Mirages, we are going to talk more on this mirages, okay? And how mirages are formed, all right? So that's that for that. So total internal reflection is also applied by fish or by reptiles for defense. When they are in water, for example, you know that most reptiles below their body, that's the part that comes in contact with the ground, yeah, it's usually lighter. Then the above is usually darker, all right? It helps them to stay away from predators, okay? Predators who will come eat them. So if animals when they chop them now come water, come look, not be as deep as that reptile or that animal they inside that water, then that predator will see, okay? If they try to catch them, they wouldn't be able to catch them because it's like a camouflage, it's like an obstructed vision. They will not know how deep that reptile is in the water. Okay, because of this total internal reflection, as a result of total internal reflection. So the reflection of the light ray that this predator is getting from that reflection, the total internal reflection of the fish, for example, fish, okay, fish, for example, the total internal reflection of that fish is not going to be exact. That's where we now see apparent depth and real depth, okay. It's not going to be the real depth, okay, of the water body, okay. What that predator is going to be seeing is apparent depth, all right. I already taught real depth and apparent depth. Now let's look at the uses of optical devices. What are the uses of optical devices? The first one is in periscope, okay. Uses prisms to view objects not in direct line or sight. So objects that are not in direct line of sight, maybe object they inside pipe, something, a closet, you use periscope to view it, and through the help of what? Optical device. And what is the optical device used in periscope? It's prisms, okay, prism. Now just mirror, now they put there, okay. Two mirrors at what? At angle 45. Two mirrors at angle 45. Optical devices are also used in prism, used in what? Prism, binoculars, and periscope for reflection, all right. So any device that uses reflection, all right, reflection that needs the bouncing off of light ray, optic applies to it. It is also used in binoculars, such as prism binoculars. Remember, prism binoculars is used for some eye defects, okay. Prism binoculars is used to shorten length and improve vision, especially when a person has more than one eye defect in one eye. They use prism binoculars, adding two prisms together to correct a lens defect, all right. So it's also used in optic fiber or fiber optic. Fiber optic uses total internal reflection to transmit light signals, telecommunication, and medical endoscopy. So these, in essence, are also the uses of total internal reflection. Mirage formation. I promise that we are going to look at this mirage formation separately because Jamb says we should be grounded in it, all right. Mirage. How does mirage occur? Mirage occurs in hot region where light from the sky undergoes total internal reflection in layers of hot air near the ground. Mirage occurs in hot region. Take note of that it occurs where? In hot region. When light from the sky undergoes total internal reflection. Light from the sky undergoes total internal what? Reflection. Travels from a denser medium to a less dense medium. The total internal reflection occurs in the layer of hot air. That hot air, so remember, it occurs in hot regions, okay. So when light from the sky undergoes total internal reflection in layers of hot air near the ground, that's mirage for you. Undergoes total internal reflection in layers of hot air. And this mirage appears as water on the road, but is an optical illusion. So when you are driving on a road, when you look further, you look front for that road, you are going to, it's going to give this impression of that place, that road is wet. That portion is wet. But when you get there, you are going to discover, you are going to find out that that road is just like the road you have been plowing, okay. It's just like the road you've been plowing. There's no difference, no water, nothing. So that's that. It's an illusion, okay. It's an illusion. It appears as water on the road, but it's an optical illusion. It's an illusion. It's not real, okay. It is not real. You see it from afar as if the road is wet, you understand, but the road is not wet. So that's mirage, okay. Ray tracing through prism. Incident ray bends towards the base inside the prism. When you are tracing ray with prism, incident ray bends towards the base inside the prism. What happens again? Emergent ray bends away from the base. Overall deviation depends on prism angle and refractive index. Overall deviation. When you say overall deviation, it's just like bending. Overall bending depends on the prism angle. At what angle was the prism placed? That's how we determine the bending of the light ray, okay? And also the refractive index too, all right? So emergent ray bends away from base, incident ray bends towards the base inside the prism, and overall deviation depends on the angle of the prism and refractive index. Dispersion of light and colors. Electromagnetic spectrum. This one, Jamb like this thing. Dispersion of light and colors. Electromagnetic spectrum. First of all, we have to understand the meaning of dispersion of light. Dispersion of light is to split light into its colors, to separate the components of light. Most of the time, it's white light, okay, that we are dispersing, all right? Separation of light, separation of white light from its components. You are separating that. White light has about 7 components. The rainbow, okay? So those components, you have to separate them. So it is separated through dispersion, all right? That's how you separate them. So in dispersion, prism splits white light, okay. It is a prism that you use to what? To separate the components of white light, okay. Violet bend most. What it means is that violet disperse most, okay. Violet bend most. Remember, violet is the last, okay, in rainbow, okay, the rainbow color. Rogue is the acronym. Rogue. Violet is the what? Is the last, and it bends what? Most. So when you are separating a pure spectrum light, use slit for monochromic light, all right. Use what? Slit for monochromic light. It is a slit that you are going to use to separate a pure spectrum monochromic light. And what is a monochromic light? A monochromic light is a light that have just a single component, such as laser light. Just one single component. It's not like white light, all right? So now let's look at the colors, the types of colors. We have primary and secondary color. What are primary colors? Primary colors are natural colors, okay? They exist naturally. They are found naturally. Not only that they are found naturally, they are also used to make other colors called secondary colors. All right. We also have tertiary colors. We have primary colors, we have secondary colors, and we have tertiary colors. All right. Primary colors include, remember, they appear naturally and they are also used to form other colors. All right, such as the secondary and the tertiary colors. All right. So the primary color are only three. The primary colors only three. They include red, blue, and green. Red, blue, and green. Three of them. Okay. Now the secondary colors. The secondary colors are the colors obtained by mixing two primary colors. When you mix two primary colors, you get secondary colors. All right. And how do we mix to get secondary colors? Let's do the common ones that Jamb always sets. All right. The first one is when we mix blue and green, two primary colors, blue and green, we are going to get what? Cyan. Cyan is a color that resembles purple in it. Okay. It's like thick purple. Cyan. When we mix red plus blue, we are going to get yellow. Please know all these things. So the one that you will mix to get the particular secondary color you will get. When you mix red plus green, you will get magenta. Okay. Magenta is almost like purple, but it's very light purple. You get magenta. So blue green gives us cyan, red blue gives us yellow, red plus green gives us magenta. All right. Then what is tertiary color? Tertiary color is a color obtained from mixing two or more primary and secondary color. Secondary color is when you mix two primary colors, you get secondary color. But for tertiary color, you will have to mix a secondary and a primary together to get a tertiary color. So addition. So how do we mix these colors? How do we mix colors? We mix colors in two ways. Okay, you can either mix them through addition, which is the red, green, blue. That's this one, the primary colors, or you can mix them through what? Subtraction of pigments. Subtraction of what? Pigments. All right. So just know that there are two ways you can what? You can mix colors. Okay, you can form secondary colors. You can either form them through the mixture of red, green, and blue. That's for white color. That's if you want to form white color, or you use the subtraction method where you use color pigments. Now, what are objective colors? Objective color is that color reflected when all the colors of an object has been absorbed. Objective color is that color that is what? That is reflected when all the colors have been absorbed. So, for example, when I put on a red rose shirt, for example, and I walk through a red light, okay, for example, okay, that red light, which is the objective color, is going to absorb all the colors, is going to absorb the rose color, and is going to reflect only red, okay, making it an objective color. So, what are color filters? We use color filters to what? To transmit specific colors. We use color filters to what? Transmit specific colors. What color do you want to be reflected? Okay, like this my dress now. You can see different color, or one color like the white color that has different components. What color do you want to reflect? Do you want to appear? You use color filters to what? To determine the color. If you want to make red appear, you use the color filter for it. If you want to make green appear, you use the particular specialized color filter for it. So I want you to understand the use of color filters. All right. Rainbow is formed during the dispersion/reflection in raindrops. Rainbow is formed from the dispersion and reflection in raindrops. All right. And rainbow comprises of 7 colors, which is the acronym ROY-BIF. Okay, ROY-BIF. This is the acronym ROY-BIF. That's what you are going to be using to remember it. And when you want to separate the colors of the rainbow, you want to disperse the colors of the rainbow, which has the highest dispersion or scattering rate, and which has the lowest dispersion or scattering rate. If you go like this, from left to right, is the increasing dispersion. So as you go like this, you move from left to right, dispersion of these colors increases. All right. So if you move like this to here, the highest will be V, which is violet, while the lowest will be R. Okay, dispersion. Okay, but when we are talking about decreasing dispersion, moves from right to left. All right. So from right to left, decreasing dispersion. So this one, violet, has a higher one than I, which is indigo. I has a higher dispersion than B, which is blue. Blue has a higher dispersion rate than G, which is green, and so on. So I want you to know that from left to right is what? Increasing dispersion. From right to left is what? Decreasing dispersion. So let's know what each of those letters in the ROY-BIF stands for in the rainbow. So this is the rainbow, you know. So if they're asking you what are the 7 colors of the rainbow, you say ROY-BIF. Then you use this ROY-BIF to remember them: red, orange, yellow, green, blue, indigo, and violet. As easy as that. Easy peasy. Colors of the rainbow. Why objects have colors? Because of objective color. Why objects have colors? Okay, objects have colors because they reflect certain wavelengths of light and absorb others. Okay, so the color of an object depends on the color that it reflects. All right, the color that it reflects. A light can be shown on a fabric like this, my fabric, for example. The light absorb all the color of that fabric and leave just one color or 2 colors. Okay, that color is the color of the object, the one that is reflected. Okay, the one that is left after absorption of the color. Okay, for example, let's look at the example we have here. A red object reflects red light and absorb other colors. All right, so a red object, we reflect that it's a red light. Okay, it's going to reflect it. You know that it's red now, so it's going to reflect a red light here and absorb all of that color. So that color that it reflects is its color. Any other color, it will absorb it. All right. So analyzing colors with color filters. Remember what you use color filter to do. Okay, depending on the color you want to be reflected. That's when you use color filter. And there are various types of color filter depending on the color that you want to transmit or the color that you want to filter. Color filter allows only certain wavelengths of light to pass through it. So the color formed by object is dependent on the wavelength of light. Jamb can also set this kind of question for you. It depends on what? The wavelength of light. Alright? And filtration of color also depends on the what? The wavelength of the light too. Alright? So only certain wavelength of light passes through some colors. Alright? So that's the feature of a color filter. The characteristic of a color filter is like a semi-permeable membrane that allows certain size of molecule to pass through it. That's what we have here. Color filter of light allows certain wavelengths of light to pass through it. Alright? So example is a red filter transmits red light but absorb all of that color. So if the color filter is a red color filter, alright, it's going to transmit only that red because it's for red color filter. Then it's going to absorb all of that color because of the difference in wavelengths. Okay, so the wavelength of the wavelength of red color or the red light, okay, the wavelength of the red light is within the range of what the color filter can transmit. The other color that it absorbs is not within the range of the wavelength that it can allow to pass through it. It's just like a semi-permeable membrane. All right, if we've done osmosis before. So what are the uses of color filters? It is used in photography, stage lighting, and scientific experiments. Now we are looking at monochromic light. What is monochromic light? It's a light that consists of just one wavelength of color, like I told you before. Okay, just one wavelength of color, Examples of monochromic light. Remember, mono means one, chromic means light or color. Okay, that's monochromic light, one wavelength or color. All right, one wavelength or color. So monochromic light is a light that has what? One wavelength or color, either one color or wavelength. Mono means one, chromic means light. Okay, mono means one, chromic means what? Color. All right, so one wavelength or color. They can ask you as what kind of light has one wavelength, okay, or single wavelength, or they can ask you saying what kind of light has one color. Which are you going to pick? So examples include light from a laser beam, the same example I gave you earlier. So what are monochromic lights used for? It is used in optical experiments such as interference and diffraction. Remember what interference is and diffraction is. Interference is when wave meets or overlap. Okay, when wave meets, wavelengths, two wavelengths meet or overlap. You have constructive interference when the two waves are moving at the same what? Velocity and at the same level. Then you have destructive interference when one wave they down, the other wavelength they up. They move together is destructive. All right. So diffraction of light, you know what it is? When light spread when it passes through a small or a tiny surface, or when light bends when it passes through a closure. Now that you have understood optical instruments, colors, electromagnetic spectrum, color spectrum, and so on and so forth, let's now take some Jamb must repeat questions to test how well we understood this topic and know how ready we are for Jamb UTME 2026. Jamb must repeat questions. Question 176. Primary colors of light are A. Red, yellow, blue. B. Red, green, blue. C. Yellow, cyan, magenta. D. Red, blue, green. What's the answer? Drop the answer in the comment section. Question 177. A rainbow is formed due to A. Reflection only. B. Refraction only. C. Dispersion and reflection. D. Diffraction only. What's the answer? Drop the answer in the comment section. This lecture note is available. Try to get this lecture note. Send me a DM. Question 178. Which has the longest wavelength in the electromagnetic spectrum? A. Radio wave. B. Visible light. C. X-ray. D. Gamma ray. What's the answer? You know the answer, right? Drop the answer in the comment section. This material is available. This short simplified notes with Jamb must repeat questions for your practice, testing each topic as you go. It's available. Send me a DM to get your copy. Question 179. Monochromic light has A. Multiple wavelengths. B. One wavelength. C. No wavelength. D. Variable wavelengths. What's the answer? Drop the answer in the comment section. I know you know the answer. I know you know the answer. Question 180. The source of ultraviolet radiation is A. Radio antennas. B. The sun. C. Microwave. D. Gamma rays. What's the answer? I know you know the answer. Drop the answer in the comment section. Electromagnetic spectrum. The first we are treating under the electromagnetic spectrum is radio wave. What is the meaning of electromagnetic? Electromagnetic can be defined as when electric currents bring about a magnetic field. That is electromagnetic field or electromagnet. Electric current brings about magnetic field of attraction. So that spectrum formed when an electromagnetic field of attraction is induced is electromagnetic spectrum. So you have various types of spectrum formed when electromagnetism is induced. So that's what we are treating. The first spectrum is radio wave. And what is the source of radio wave? It has natural source and artificial source, which is the transmitters. Transmitters is the artificial source. And what is the main use, the major use of radio wave? It is used in wireless communication, phone call, airing of news on air, radio station, television, all those things. You use radio wave, okay? They use radio wave, okay? They work under the principle of this particular electromagnetic spectrum, radio wave. How is radio wave detected? It is detected through radio wave detector, okay? A radio wave detector tube. That's what you use in detecting radio wave, all right? Your radio at home is a device that detects radio wave. Hope you know. The second electromagnetic spectrum is infrared. Okay, what is the source of infrared? Through a hot body. What is the use of infrared? Infrared is used as a heat source and for communication. For those of you who they use electric cooker for house, okay? Most of those electric cookers are infrared cooker, okay? They also use it for thermometer. They have infrared thermometers, all right? It is used for communication. Remember that time when Bluetooth never come out, now infrared will take the send file. Infrared, now we take the send file, okay? So infrared is used for communication. It's used in phone calls too, all right? It's used in communication, all right? And what is the detector of infrared? It is detected with a device called thermopile. The next electromagnetic spectrum is visible light. What is the source of visible light? Very hot body. Infrared is through a hot body, but visible light is through a very hot body. What is the use? Power and heat source, okay? It is used for power, our electric power we basically get. Now through visible light we take the get them. And heat source, you can also use visible light as heat source. You know they use lights for heat. When you spread your clothes for sun, you know they dry. And how is visible light detected? It is detected with the what? The eye. The eye detects what? Light, the presence of light. Okay, remember light is that which brings about the what? The sensation of vision. The next electromagnetic spectrum is ultraviolet ray. I am going to give you a simple acronym that you are going to use to remember all these, you know, all these electromagnetic spectrum arranged in order, because you have to arrange them in order so that they ask you question puts, especially question pertaining to their wavelengths or their frequencies, you'll be able to answer. Arrange them in order. I will give you the acronym, just like I gave you Roy Beef. I will give you this one, but it's not time yet. Ultraviolet ray, the source of ultraviolet ray is the sun, all right? The sun is the source of ultraviolet what? Ray. And what is the use? It is a source of heat, okay? It is a source of heat, and plants uses it to photosynthesize, and also vitamin D source. When you are exposed to sunlight or ultraviolet light, you know what happens? Your skin begins to what? To convert this energy from the sun or this ultraviolet ray to vitamin D. So what is the detector for ultraviolet ray? The first one is the eye. The second one is the ultraviolet sensor. All right. So what does this ultraviolet ray cause? What is the effect of ultraviolet ray? What is the cause us? Okay, it cause sunburn and skin cancer. Ultraviolet ray. The next one we have is S-ray. And what is the source of S-ray? Through radioactivity. We already discussed radioactivity in chemistry. And what is S-ray used for? Medical diagnostics. You know, diagnostics in medicine. Okay, to ascertain what is wrong with the patient. Okay, you use this S-ray helps you to see inside the body of the patient to know what is wrong, to ascertain what the problem is. Okay, that's medical diagnostics. X-ray is also used in tracers, all right, especially tracing of those elements, radioactive elements, and so on and so forth. And it can also be used, X-ray can also be used, when you say tracers, it can also be used to trace leakage, especially in pipelines, all right. X-ray is also used in cancer treatments. Yes. And how do we detect X-ray? How do we know that X-ray is present? X-ray is here. We use the Jamb counter. The Jamb counter was discovered by a German physicist. Okay, that was the person that discovered the Jamb counter. And what does X-ray cause? What can be the, you know, the undesirable effect of X-ray? X-ray can cause cancer. It can cause cancer. Okay, especially when you are exposed to high quantity of X-ray that your body can absorb quickly. Okay, when the X-ray is more than what your body can absorb quickly, because your body absorbs X-ray slowly. Okay, so if your body can quickly absorb them, they turn to what? Cancer. That is why it's safe to use X-ray for diagnostics. Okay, it's safe to some extent because the very small X-ray will enter your body. Okay, during the diagnostic, your body is going to likely absorb them. With time, your body will absorb them and it is going to keep you on a safer side. You are not going to experience any problem. You are not going to develop cancer. All right. The final one, the electromagnetic spectrum, is gamma ray, and gamma ray is gotten from radioactivity. All right. What is it used for? It is used in the same medical diagnosis, just like X-ray. It is used in sterilization of surgical equipment. Use those stainless equipment used in the hospital. You use what? Gamma ray to what? To sterilize them. Okay, this is what we call radioactive sterilization. All right. So it is also used. Gamma ray is also used in cancer treatment. So what is the detector of gamma ray? It is detected through the same Jamb counter. And what does it cause? What are the undesirable effects of gamma ray? It causes cancer. Okay, just like X-ray. I want to ask you a question now. How is X-ray formed? How is X-ray formed? Do you know? X-ray is formed through the bombardment of matter with a fast-moving electron. When you bombard matter with a fast-moving electron, X-ray is formed. For example, if I want to get an X-ray of my palm, for example, okay, I am going to place this my palm in front of this book. Let's take this book, this notebook as metal. Okay, so this is my palm. I want to get the X-ray of my palm. So I am going to put a photographic film in front of this metal here. Okay, so I will put my palm here. So I am going to direct fast-moving electron to this my palm, fast-moving radioactive electron to this my palm. Okay, immediately that fast-moving electron touches this my palm, is going to penetrate this my palm deep, and is going to come out from this other side and hit this metal. Okay, this metal here. Okay, as it hits the metal, the same electron rebound and passes through this my palm again and comes out from the other side, and it falls on what? What is in front of this my palm now? What did I place in front of this my palm? A photographic film. and it falls on the photographic film, the image of this my palm is formed. That is how X-ray is formed. The bombardment of matter with fast-moving electrons. This is the acronym to remember the electromagnetic spectrum. All right. So the acronym is REVOXC. 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 So gamma G is the last. REVOXC. The one for rainbow light. Okay. Light, dispersion of light is what? Is Roy Beef. The one for electromagnetic spectrum is REVOXC. So when you are moving from left to right, now here down for the set question. When you are moving from left to right, you will have decreasing wavelength and increasing frequency. So what this means is that as you go from left here, okay, to right here, okay, it means that as you are going like this, the wavelength is decreasing. As the wavelength is decreasing, the frequency is increasing. So I will ask you a question now. Which is the highest wavelength here and the what? The highest frequency. Okay. So since as I go like this, the wavelength decreases. Let's do the wavelength on first. The shortest wavelength here or the smallest wavelength here will be this gamma ray, because as you go, it continues to increase. Okay, gamma ray has the what? The shortest wavelength and the highest penetrating power. So if the wavelength is very short, that shows that it has a high penetrating power. But as you are going like this, since the frequency increases, the highest frequency will be what? Gamma ray. So gamma ray has the highest frequency and the shortest wavelength. So radio wave here is going to have the what? The highest wavelength and the smallest frequency. Okay. So when we now do from right to left, we are now going to have decreasing frequency and increasing wavelength. That's opposite of what we have from left to right. So what you have from left to right is opposite of what you have from right to left. So if you can remember anyone, you already know that it's the opposite. The other side will be opposite. So try to remember anyone, at least one of them, so that you can use it to predict the other. Jamb can ask you which of the following electromagnetic spectrums has the shortest wavelength. How you want to know? It is through this acronym, okay? Or they can ask you among them. See, it doesn't mean that it is gamma ray that is the answer. They are asking you shortest wavelength now, for example. It's not gamma ray that is the answer, because you might not even see gamma ray there. They might just put radio wave, they put visible light, they put ultraviolet ray and X-ray. They will ask you which has the what? The highest frequency or the shortest wavelength. All you need to do, just use the acronym to find out immediately. 10 seconds, okay? 10 seconds and you've gotten the answer, all right? But always put it in your head. I want to give you one simple expo, because this decreasing wavelength and increasing frequency can be confusing. So just know that gamma ray has the shortest wavelength, the smallest wavelength. So with that, you can use it to predict the rest. So if you know that gamma ray has the shortest wavelength, meaning that the first one, which is the radio wave, we have the what? The longest wavelength. And you know that it is opposite. Wavelength is opposite of frequency. So if I have a very short wavelength, now I'm going to have a very long frequency. All right. So that's that for that. The one with the highest penetrating power, like I told you before, is gamma ray. Okay. So the penetrating power increases with what? Frequency. The penetrating power increases with what? Frequency. And it's what? It decreases with what? Wavelength. As wavelength increases, penetrating power decreases. Remember, the penetrating power is dependent on the frequency. So the higher the frequency, the higher the penetrating power. All right. So the highest penetrating power here is gamma ray, because it has the highest frequency. The lowest penetrating power here is radio wave, because it has the what? The lowest frequency.